Hello and welcome to Easy Maths. This is the first lesson, a series of lessons on the topic of further logarithms. In this particular lesson, we're going to look at definition, and in other lessons, we look at the laws of logarithms and logarithmic equations and expressions. And so now, at this point, let's turn straight to the definition of logarithms or further logarithms. As a define, I'm going to say that this topic comes to students after a prerequisite lesson or a topic of logarithms to which students in Form 2 were introduced to. Now, having said that, let's define the concept in further logarithm. One, we're going to show how to express an equation as index or in logarithm notation. And so the equation we have, this one appearing on screen there, is normally read as 2 raised to the power 3 equals to 8. Students at this point are familiar with that expression. 2 is called the base, 3 is the index. It's also the power. Now that equation 2 raised to the power 3 equals to 8 can also be written as it's appearing on your screen there. The LOG means logarithms, short form for logarithm, and this one here is read as logarithm of 8 to base 2 equals 3. That is log of 8 base 2 is equals to 3. Now, I need to say the following. If an examiner wrote log of 8 is equals to 2, log of 8 to base 2 is equals to, say, an x, and then the person wants you to write the value of x, what does the person want from you? What the person will actually be asking for is, they'll be asking, the number 2 can be raised to which power to give 8? Right? The number 2 can be raised to what power to give 8? And that number is 3, and that's what we call the power or index in the previous expression, the index notation. Having thus said, let's look at the 3 numbers that we have in both expressions, the 2, the 3, and the 8 in the index and the logarithm notations earlier discussed. Now, the 3 numbers, the first one, 2 is a base for both expressions. Here we call 2 the base, we have also called 2 the base here. Similarly, 3, which is the power or index here, we have also called it a logarithm on the other side. And lastly, 8 is the only other number that there is in both expressions. Having thus said, let's go on to describe or show how to express the index notation to logarithm in the following. So we have 2 raised to the power 3 is equals to 8, and that means that can be written as log of 8 base 2 is equals to 3, as we have already said. Now please take note of the following. There is a 3 here which also happens on the other side, and that 3 which happens here in the index notation and logarithm notation is called the logarithm. It's also called the power. It's also an index. Similarly, we have a 2 that appears there and a 2 which appears on the other side there, and that 2 which happens to be on both sides is called the base. The only other number that there is in both equations is 8. At this point, a student should be able to express, if you're given the index notation of, say, an equation, you should be able to express it in the logarithm form, and if you're given in the logarithm form, you should be able to express it in the index form, and they both communicate the same thing. Let's try out some examples in that regard. Therefore, we have the following questions. We have 7 raised to the power 2 is 49, 121 raised to the power 3 over 2 is 1331, 5 raised to the power 0 is 1, and lastly, a 5th raised to the power negative 3 is 125. So, from what we have said, 7 is a base, 2 is a power. That means we're just going to write log of the only other number that there is, that is 49, to the base 7 is 2. That 2 is a logarithm. And there you have it. The next question, you have 101 raised to the power 3 over 2 is 1331. Therefore, it means log of 1331. The base is 101. The logarithm, which is now the power or the base here, is 3 over 2. And therefore, it appears like this. Next, we have 5 raised to the power 0 is 1. And therefore, it means log of 1, the base is 5, is equals to the logarithm of 0. And lastly, we have log of 125 to base a 5th is negative 3. Please notice that these are mathematical equations, and they must be sensible. They must be sensible. If you write an expression in a way that is not sensible, a student should be able to notice that. For example, when we write log of negative 3, say to base a fifth is 125. That's not mathematically sensible. Similarly, we cannot write log of 0 to base 5 is 1. So whatever you write, since it's a mathematical statement, it should be provable mathematically. And this can be proved, The logarithm notation equals to the, so the logarithm notation here equals to what we had been given, the index notation. Moving on to some other examples, we have log of 1 to base a is 0, log of 1000 to base 10 is 3, log of 1 is 0, and lastly log of 5 to base 25 is half. Now please notice the index, please notice the logarithm. In all of these times, the logarithms are 0, 3, 0, and half. And the bases are a, 10. We don't have a base here. It means it's base 10. And the base here is 25. And therefore, it means the bases raised to these particular logarithms should give us the numbers 1, 10, 1, 5. As follows. We have a raised to the power 0 is 1. That's the first one. 10 raised to the power 3 is 1000. That's what we have there. Where we did not have the base, we assume the base is 10. That is, whenever the base is not indicated, we assume the base is 10. So we have 10 raised to the power 0 is 1. And lastly, we have 25 raised to half is 5. Again, I should say that these expressions should be mathematically sensible. Ensure that whatever thing you get, the expressions are mathematically sensible. Having that said, I've come to the end of first lesson. Please check out for more as we go on now to the laws of logarithm. Thank you.